Alright, we first try to get the augmented matrix for this system, and this is what we have. Alright, so we have augmented matrix over here. Be careful because we have some terms missing. So we have 2, -2, 4, and 0, 0, because there is no z term in the first equation. And then we have -3, 3, and -1, and we have 5 and 15. 1, -1, 2, and 0, and 0. Now, the first step is try to find a pivot. And we know, we look at the first column, we see over here there is a 1 over here, so we're going to swap the first row and the third row, R1 and R3, swap, so we have the following. We have 1, -1, 2, 0, 0. Well, you may say that you don't really need to do so, because you can simply rescale the first row to get the same kind of row, exactly the same row. But imagine that if we don't have this special row over here, this is the first natural step. And then we want to eliminate these two entries, -3 and 2 over here. So we do it one by one. We have the following. So first row 3 times the first row and add it to the second one. Let me turn around. So this is what we have, and this is over here. We have 1, -1, and 2, and 0, and 0. And fortunately we have 0 over here and 0 over here. And then 2 times 3 is 6. 6 plus -1 is 5. So we have 5 and 15 over here. We can actually do the last one together, but let's just copy one more time. Alright, okay, so we have this one over here, and then we multiply -2 to first row and then add it to, sometimes we use this notation, it's probably better, and then we have the following. We have 1, -1, 2, and 0, and 0, and 0, and 0, 5, 5, and 15, and 2. Oh, this is going to be 0 now. Okay, 0. And then this is going to be 0 again, and this is going to be 0, and 0, and 0. So we have a 0 row over here. Let me erase this part over here. So we have a 0 row, and that's good. And let's divide 5 over here. So we have 1/5 of R2, and then we have 1, -1, and 2, 0, and 0. And then we have 0, then 0, and 1, and 1, and 3, and 0, and 0, 0, 0, 0. Now, this one is in the so-called row echelon. This is already now in row echelon form. Okay. Now, we are going to find leading ones over here. This is the one that is very useful. Find leading one. Find leading one over here. We look at each row over here. The leading one is this one. The leftmost non-zero term over here. This is the leading one. These two are the leading ones. These are the leading one. Okay. Leading ones. So how do we find them? We look at each row and look at the leftmost non-zero entry. If it's not 1, then we can always divide that number through and get 1. So these are called the leading ones. Okay. Now, we know among these 4 columns, this one is W, this one's X, this one's Y, and this one's going to be Z. We look at these columns corresponding to our variables, and we look at the columns without leading ones. So this one doesn't have a leading one, and this one doesn't have a leading one. So let's write down this one over here. So we say, find the leading one we have over here. We can use notation. A11 is the leading one. Okay, so this is A11 is the leading one. And then we can see we have A2, 3. This is a leading one. Okay. Now, columns, we see these columns 2 and 4. They do not have leading ones. What it implies that the corresponding variables are the free variables. So now we turn this augmented matrix back into the system. What we have over here is something like this. We have x minus y plus 2z is equal to 0. And we have over here x, no, it's wrong. Okay, let's do it over again, because the first one isn't x, the first one is w. So what we have over here is that we have w minus x plus 2y is equal to 0. And then we have over here y plus z is equal to 3. Okay. And we have free variables over here. We have x and z. And what do? We move these free variables to the right hand side. So what we have now is w plus 2y is equal to x. And then y is equal to 3 minus z. Okay. Now we are almost done. Now we solve y and we solve the rest of the variables. We solve we solve w, y in terms of free variables x and z. So what we have over here is that y is equal to 3 minus z, and w is equal to x minus 2y, and that's going to be x minus 2, 3 minus z. So we have over here x is equal to, now w over here, we have w is equal to x minus 6 and plus 2z. Now we write down this vector form. We start from w, x, and y, and z. And this is equal to, we look at w, that's going to be negative 6 plus x plus 2z. Okay, and then we have x is simply free variable, so we just write down x. Then y is going to be 3 minus z. Okay, and last one is simply z. Okay. Now we somehow decompose this vector over here according to constant vector, which is -6 over here, and there's nothing, 0. So, and this one is going to be 3, and here it's going to be 0 again. So constant vector. And then look at the coefficients in front of x. So we have plus x, and look at this one's 1 and 1, because we see over here is 1 and 1. And here we don't have any x, so it's 0. And last one is over here again, 0. And then we look at z over here. And then what we have is 2 over here. And then we have 0 and -1 and 1 over here. Now we turn the free variables into parameters. So we have something like this: -6, 0, and 3, and 0. Okay. And then plus s over here, we have 1, 1, 0, 0. And then plus t over here, we have 2, 0, -1, and 1. S and t are arbitrary, so we write down st, they are in the real number system.